In the previous lecture, we did states of matter, where we did three states: solid, liquid, and gas, and the factors or the conditions by which we can change solid to liquid or liquid to gas. Solid to liquid is melting, and liquid to gas is evaporation, and solid to directly gas is sublimation. We did certain physical terms associated with this change, like latent heat of fusion. Fusion is for melting, either melting or fusion, both is same. So, latent heat of fusion, like when 1 gram solid changes into liquid, or latent heat of vaporization when 1 gram liquid changes into gas, or the latent heat of sublimation when 1 gram solid directly changes into gas. Similarly, we did heat capacity, that is the heat required to increase temperature of solid by 1 degree, or the temperature of liquid by 1 degree, or temperature of gas by 1 degree. Our today's lecture is based on laws of chemical combination. So we'll do first law of conservation of mass, that is also known as law of indestructibility or Lavoisier's law. According to this, the total mass of matter will not change in physical as well as in a chemical process. Like matter can be changed from one state to another state, but during that process, its mass will remain constant. Like if we take 100-gram ice, on heating, it will give 100 gram of water. It is a physical change, but the mass of matter remains same. Similarly, if we consider a chemical change, like a precipitation reaction, this is a Landau tube. There are this H-shaped tube, and one block having NaCl, the other having silver nitrate. Before mixing these two solution, we'll take the weight of this tube, and after mixing, there is displacement reaction, and white precipitate or silver chloride appears. Even after that, the total mass will remain same. So this will prove law of constant conservation of mass, or the law of indestructibility of matter. We can use this law in this way. Consider this chemical reaction. Mercury oxide on heating give mercury and oxygen. So if we take 100 gram of mercury oxide, which is a solid, on heating, the residue left will be liquid mercury, and its mass was found to be 92.6. By knowing this mass, we can easily find out how much oxygen gas will release. Obviously, the oxygen will be, the total mass of product will be equal to the total mass of the reactant. If it is 100, it is 92.6. Then 100 minus 92.6 will be 7.4. So 7.4 will be the mass of oxygen released. So by this way, we can easily know how much products will be formed. Any one of the products can we find out. So matter is neither gained nor lost, but can be changed from one form to another form. But this law has one limitation, especially in nuclear reactions. In nuclear reaction, large amount of heat is released, and this heat is released when some mass changes into heat. Here, the mass of total product in a nuclear reaction is slightly less than the mass of the reactant, because during reaction some mass gets changed into energy. And according to Einstein's equation, E is mc square. If this is the mass, decrease in mass, that is the difference of mass of reactant and product, and c is the velocity of light, 3 into 10 raised to power 8 meter per second, we can find out that how much energy will be released by knowing the decrease in mass. Experimentally, it was found that if the decrease in mass is by 1 atomic mass unit, then 931 mega electron volt energy will be released. That means if the difference in mass is too less, the energy released will be more. So this law was modified. Now the statement is law of conservation of mass and energy. But still, in a chemical reaction, we can easily apply law of conservation of mass because the energy changes or the heat released during chemical reaction is very less. Just we'll do one more example. Calcium carbonate. If we take 100 gram of calcium carbonate, it will give 56 gram of calcium oxide. Then how much of CO2 will be formed? This we can easily find out by the difference. This is 100 and the solid left is 56, remaining will be 44. So suppose instead of 100, if we take 200 gram of calcium carbonate, double calcium carbonate, then double residue will be formed, 112 gram, and the double CO2 will be formed. So this is the application of law of conservation of mass, right? Now second law is law of definite proportion or the constant composition. According to this law, in a chemical compound, element always combine in a definite proportion by mass, irrespective of the source of compound. For example, in pure water, whether it is prepared in laboratory or it is natural, in pure water, hydrogen and oxygen they are always combined in which mass ratio? You know that mass of hydrogen is 2 hydrogen. One hydrogen has 1 atomic mass and one oxygen its mass is 16. So what is the mass ratio of hydrogen and oxygen? It is 1:8 and it will always be same. So in compound element they combine in a definite mass ratio. But in case of isotopes, this ratio may be changed. Like if it is CO2, CO2 having carbon isotope carbon 12, then ratio will be 12:32. But if carbon is present as isotopes carbon 14, then this ratio will be different. So we have to mention which isotope we are using for this law. Same, instead of water, if we use heavy water, in water it ratio is 1:8. Mass of deuterium is double than that of hydrogen. If hydrogen has 1 atomic mass, deuterium will have 2 atomic mass. If there are 2 deuterium, then total mass will be 4. And oxygen is 16. So this ratio instead of 1:8 is 1:4. So one limitation of this law is when isotopes are involved. Second limitations. Different compounds can have same mass ratio. For example, in isomers, this is ethanol and this is ether. Both have same formula, C2H6O. These are two different compounds, but the ratio of carbon, hydrogen and oxygen by mass or by number is same. Carbon, 2 carbon 24, 6 hydrogen 6, 1 oxygen 16. So this ratio is 12:3:8. So we can say that even different compounds can have same mass ratio. Just see this example. It is ethanoic acid and this one is glucose. If we simplify this ratio of carbon, hydrogen and oxygen, there are 2 carbon, 4 hydrogen and 2 oxygen. The simplest ratio is 1:2:1. In glucose, its molecular formula is C6H12O6 and the simplest ratio is same. So the simplest ratio of mass or the number can be same even for two different compounds. These two compounds have different molecular formula, but they have their simplest ratio of atoms, that is same. So with some limitations, we have to use this law. Next law is, this law was given by Dalton. You must have done Dalton theory also. This is law of multiple proportion. According to this law, when two elements combine together to form two or more compounds, then fixed mass of one element react with different masses of other element, then the ratio of masses of other element will always be in multiples. I repeat this definition. When two elements combines together and fixed mass of one element combine with different masses of other elements, then the ratio of other element is always in multiple, simple integral ratio. For example, in this question, nitrogen form different oxide with oxygen. Here N2O, NO, N2O3, N2O4, N2O5, 2 nitrogen, 1 oxygen. 2 nitrogen is 28, 1 oxygen is 16. 2 nitrogen react with 16 oxygen, then 1 nitrogen will react with how much oxygen? 8 oxygen. Second example, 1 nitrogen 14, 1 oxygen 16. So the mass ratio of oxygen is now 16. In third example, 2 nitrogen, 3 oxygen. 2 nitrogen is 28 and 3 oxygen is 48. If it is 1 nitrogen, that is 14, then oxygen will be 24. If it is half, it will be half. Next, N2O4, 2 nitrogen and 4 oxygen. 2 nitrogen is 28, 4 nitrogen oxygen is 64. How 64? 1 oxygen has 16 mass, 16 into 4, 64. If we fix the mass of nitrogen to 14, then mass of oxygen combined will now be, how much it is? 32. If it is half, it will be half. Same in N2O5, 2 nitrogen, 28, 5 oxygen, 80. If we fix the mass of nitrogen 14, then mass of oxygen will be 40. So what is the mass ratio of oxygen? It is 8, 16, 24, 32, 40. And the ratio of mass of oxygen in these compound, it is 1 is to 2 is to 3 is to 4 is to 5. So fixing the mass of nitrogen 14 parts mass of oxygen in these compound will be in multiples. I think this law will be clear to you. In all the oxide, we have fixed the mass of nitrogen. If nitrogen is 1, oxygen is 1, formula will be NO, and the ratio is 14 gram nitrogen combined with 16 gram of oxygen. But in NO2, 14 gram combines with 32. So ratio of oxygen in NO and NO2 is 16 is to 32. So again it is 1 is to 2. Same in case of water and H2O2. In water, 2 gram hydrogen combined with 16 gram oxygen. But in H2O2, there are 2 hydrogen. So 2 gram hydrogen combines with 2 oxygen, that is 32 gram oxygen. The mass ratio of oxygen in these two compounds is 1 is to 2. But now this law has many limitations because now many other compounds are known in which there is elements combined in fractional ratio. So now the mass ratio is not in multiples because elements have this fractional ratio. Iron oxide, its one form also exists as iron 0.93 and oxygen 1. You will know how these compounds are formed, but this law has these limitations. Non-stoichiometric compounds. Just we do some numericals. In your school exam, in subjective paper, some numericals will be there, and you have to prove which this numerical will prove which law. 0.7 gram iron. It combined with zero point 0.4 gram of sulfur. Iron and sulfur, they combine to give iron sulfide. Now, what is the mass ratio of iron and sulfur in this compound? 7 is to 4. 7 gram iron combines with 4 gram of sulfur. Now, in second experiment, we have taken 2.8 gram of iron. It was dissolved in HCl to give ferrous chloride. Then excess of sodium sulfide was added and ultimately iron sulfide is formed. And how much iron sulfide was formed? 4.4 gram iron sulfide. This is the mass of iron. This is the mass of iron sulfide. And the difference of these two will be the mass of sulfur, which combine with this iron. So just will make this table. In first experiment, iron is 0.7, sulfur is 0.4. Ratio is 7 is to 4. In second experiment, iron is 2.8 and iron sulfide was 4.4. Difference of iron sulfide minus iron will be sulfur, and sulfur is 1.6. So what is the ratio? 2.8 and 16, 28 is to 16. And if we simplify this, it will be 4 is to 7. So this ratio is same. That means the mass ratio of iron and sulfur in these two compounds will remain constant. So it is law of constant composition. Which law was proved? Law of constant composition was proved. You can note this question. Zero point 0.7 gram of iron combined with 0.4 gram of sulfur to form iron sulfide. If 2.8 gram of iron was dissolved in dilute HCl, an excess of Na2S is added, 4.4 gram of iron sulfide was precipitated. Prove law of constant composition. Right? Next question. Carbon and hydrogen, they combine to give different hydrocarbon. Illustrate the law. In first, 75 gram carbon combined with 25 gram hydrogen. In second, 85.7 gram carbon combined with 14.3 gram of hydrogen. In third, 92.7 gram carbon react with 7.7 gram of hydrogen. Which law can be proved? You have to fix the mass of one element, like 25 gram hydrogen combined with 75 gram carbon, then 1 gram hydrogen combined with 75 by 25 gram of carbon, that is 3. Same in second case, we have to calculate carbon by hydrogen ratio. And same in third case, we'll have to find carbon by hydrogen ratio. And this ratio was found to be nearly 6:12 approximately. So, what is the ratio of carbon which combined with fixed mass of hydrogen is 3 is to 6 is to 4? It is in multiples, integral multiples. So, which law is proved? Law of multiple proportion. If in the three experiment this ratio was found to be same, then it was the law of constant composition. And you can say that in every case compound formed was same. Do this question. What mass of NaCl would be decomposed by adding 9.8 gram H2SO4 if 12 gram of NaHSO4 and 3.65 gram of HCl were produced in a reaction, assuming law of conservation of mass. What is the reaction? NaCl react with H2SO4, and you have to find how much NaCl would be taken, so that by reacting with 9.8 gram H2SO4 you will get 12 gram of sodium bisulfate and 3.65 gram of HCl. Here mass of product is given. NaHSO4 12 gram, HCl 3.65 gram. What is the total mass of product? 15.65 gram. If H2SO4 is 9.8, what will be NaCl, and mass of both sides is same? So what is X? What is X? It should be around 5.85. You can check this question. Right? 5.85 gram. So today we did two laws, which first was the law of constant, law of conservation of mass, then law of constant composition, and this was the law of multiple proportion. And we did the use of these laws in chemical reaction. Next important law, Gay-Lussac's law of combining volume. This we will do in the next lecture. First, revise these three laws, and this law is going to be very important law. This we will do in the next lecture.